This is a download from the BBC. To find out more, visit bbc.co.uk/Radio 4.
Ladies and gentlemen, boys and girls, XX and XY of any age, welcome to a no-holds-barred, bare-knuckle, infinite monkey cage fight. Because today we have the fight of the century in the left corner, presenting a majestic view of a universe populated by 350 billion galaxies, countless stars and planets of unimaginable beauty, weighing in with masses generated through the interaction of their particles with a condensate filling every corner of the universe with an energy density of a staggering 10 to the 37 joules per cubic metre. That's the power output of the sun in 1,000 years. It's physics! And in the right-hand corner with coloured liquid and funny smells, it's chemistry. I'm Robin Ince, and in the interest of truth, I'd like to make it clear that Brian Cox wrote the chemistry introduction.
And I'm Brian Cox, and I refute the accusation with all the strength of a homeopathic nuclear power station.
They're perfectly safe, but why won't my light switch on?
Joining me to battle this out is a man who studied mathematics and theoretical physics at University College Dublin, but went on to become a stand-up comedian. He occasionally mixes the two, but finds that any joke that starts, if we take X to be the IQ of a man who walks into a bar, Y to be the IQ of the parrot on his shoulder, and Z to be the height of the bar in feet, and Z is greater than Y is greater than X, then you must be at an equine Reiki and Feng Shui acupuncture and astrological homeopathy convention, doesn't play well at equine Reiki and Feng Shui acupuncture and astrological homeopathy conventions.
Though, that said, Brian, I've noticed that our invitations to speak at equine Reiki and Feng Shui acupuncture and astrological homeopathy conventions have diminished since this show started.
Yes, it's the primary non-exponent of equine Reiki and Feng Shui acupuncture and astrological homeopathy, Dara O'Brien.
Well, we will, as you've seen who represents physics there, that's Brian and Dara, but representing chemistry in a fug of ether and stinking of something sulphurous is our first fighter for the chemistry way. He's the BBC's go-to inorganic chemist if you want a demonstration on how alchemists distilled urine with the hopes of creating true gold, and therefore has a very small social circle. He is Andres Sella, and we have someone who will be our first guest who appeared 3 times on this show so far. He is the Pro-Vice-Chancellor of Sheffield University and a chemist. His last appearance in the monkey cage culminated in the call for the crowds at Glastonbury to mince more in order to avoid sinking in the mud, which has led to an enormous amount of wolf whistling against West Country farmers and a lot of very confused sheepdogs. So it is Professor Ryan, Tony Ryan. And these are our fighters for this evening. So, let's start off, in fact, by you offering your evidence. Brian and Dara, I would like to know, why is physics the greatest discipline achieved by human imagination?
All I thought we had to do was beat chemistry. I didn't think we also had to win. And the secondary question was to actually beat everything else as well. Listen, physics is a science because physics has the breadth, physics is a vision, physics can allow you to write the entire equations that govern the universe on a blackboard. Physics, unlike chemistry, cannot be preceded by the words "boots the." I mean, ultimately, I think the debate will get into the issue of whether chemistry is really merely a subset of physics, and by extension, is physics just a subset of mathematics? So that may be one direction it'll go in. Other than that, what would you want to answer?
I think I'm going to start off being sensible, surprisingly, and until Tony winds me up and becomes increasingly bellicose in his defence, and then I'll be less than sensible. But I suppose the debating point, is whether... So physics is the description of the fundamental building blocks of nature and the forces that stick those together and make nature operate. So I suppose the real question for the sciences, chemistry and then biology and so on, is whether it's possible to derive behaviour in principle, such as chemistry or even biology, or even derive a whole universe from the fundamental laws in principle. If it is possible, then, of course, then physics is the fundamental science because it's the study of the fundamental laws. But it's not clear that you can derive a human being or you can derive a star. And in fact, at the moment, although we have the basic laws of quantum theory, which tell us how electrons behave around atomic nuclei. We can't precisely predict the structure of even the simplest molecules. So I suppose the interesting question in this programme is whether, to what extent, we might ever expect a basic theory of everything to be able to predict all the emergent complexity of the universe that we see.
So chemistry in some ways has the advantage because it stops at a point where we can still comprehend it, whereas physics rather arrogantly just keeps on going and then goes, I'm a little bit lost.
Well, yeah, we just say, well, we've got the fundamental laws and the rest of it is not really particularly interesting, which is, of course, nonsense because human beings and civilizations and planets and stars and galaxies are interesting, and even molecules and chemical reactions.
This isn't quite the anti-chemistry slam down I was hoping you'd give. No. If anything, you give them rather amount of wriggle room at least. There. So yeah, we got to work on our tactics as a tag team here at this stage.
Over to so I think you're in the lead so far, and you haven't given your case yet, which is very good. A wonderful moment. So Tony Andrea, what would you say in defence of chemistry?
Well, we could have waited, and we have done. We could have waited for you to derive all the laws, but actually, we've just got on with it. We've just got on with making people's lives better through coloured water and smells, right? So this morning I was teaching a second-year chemistry class, and I asked them, what should I tell Robin and Brian about chemistry? What good is it? And the answer came back, well, the answer was a long list of things, but food. So the first cooking was chemistry, and that's what allowed us to differentiate ourselves from the other animals and our brains to grow so that we could eventually produce physicists. And colour. Can you imagine how dismal your life would be without the colours that synthetic chemistry brings you? But most of all, they said, there wouldn't be the Brian Cox as we know him because there'd be no hair care products, no anti-wrinkle cream, no tooth whitener.
To be fair, he does use physics for that as well. A lot of it is computed when he's on screen. If you compare that to what you normally see next to a volcano, it's very different without CGI. Andrea, what would you say?
Well, I think Tony said an awful lot of it. I mean, the French 19th century chemist Berthelot said, "La chimie crée son objet." Chemistry creates its own subject. I mean, it's really the most creative and the most constructive science. And all you have to do is just look, for the audience, just to look in front of you and around you. And all of the colors, all the materials you see, everything you see is a product in some way of the chemical industry, whether it be the gels and the lights, the colors in the curtains, the actual material that the curtain's made of. And so, yes, you've got physics working at a deep level underneath. But at the end of the day, putting a whole pile of equations on the board doesn't feed you, and it doesn't make you look gorgeous.
Now, Mr. Jane Doris, someone who studied mathematics and theoretical physics. Now, physics, I sometimes wonder, chemistry we have got, it deals with the world that we see. It deals, created mauve, as you were bigging up there. At what point, physics sometimes I worry actually becomes more like philosophy. You see it kind of being used more and more.
Go away!
But it does. You get this
the good
point
old
where
days where physics was mainly philosophy. I mean, my background was the theoretical stuff, and we were always off in a dusty corridor somewhere with chalk under our fingernails, waiting for you lot to catch up and build a giant machine to fill in the gaps of the stuff that had been invented theoretically. And physics has that, and fine. Let physics take ownership of that. The more lofty-minded will go off, and we will worry about what all of this means, right? And let them do some engineering and making, colours and cloth and new type of freeze-dried food, whatever it is. They're claiming colour earlier on. Both of them claimed ownership of colour. That's a fairly fundamental thing for two chemists to go, oh yeah, well, it wasn't for us. You'd have no colour. You'd live in a world of bland, a world of monochrome.
It was true there wasn't colour till what, about the mid-30s?
Round about that.
Yeah. So, I mean, this is, I suppose, again, with chemistry where, and I'm probably wrong on this, I normally am, but it's the fact that with chemistry you go, I wonder what happens with this and this, and I wonder how that will change our ideas. I know what will set up an experiment, and perhaps, hopefully, in the next few weeks, as you were saying, you could do that. Whereas Peter Higgs in the early 60s goes, I've got this idea, and it's about a particle, and I go, we should probably test that. What should we do? Well, first of all, we need to get a lot of diggers, and we need to ask quite a lot of Switzerland and quite a lot of France if we can dig into them. Then we need to build a huge, basically underground city, a system of things which then, how long will it take? I reckon we should have it ready in about 30 years, but we might drop a sandwich in it on the second day, which will mean it'll have to be turned off for another 6 months. So it's kind of... is that one of the problems where one's more can seem more immediate than the other?
Well, it can, but to be fair, chemists, I mean, the periodic table was left with all the gaps in it. The structure of it was there, and that was a theoretical construct, and then the gaps were filled in as it went along. However, the intriguing thing about it is that you learn the system in school of the orbitals, which you will tell us is wrong, and maybe it was wrong, but it still works. You know, you can still do what you're doing with this incorrect information. Am I wrong in saying that you can still use that system in order to work out your CH4s and your all that?
All of chemistry is about predicting, if you take this and that and you mix them together, how they will react. And what you have are a series of kind of heuristic rules about charge distribution and that sort of thing. You don't have to do all the quantum mechanics to have an idea of where that's going to go and to be able to rationalize it. Now, one of the things which has really changed in chemistry is that now computational chemistry has advanced so much that you can make extraordinarily sophisticated calculations of very, very complex molecules, ones in which you pull together both quantum mechanics and, importantly, for those who think that relativity may about be overthrown, but where you include relativity in the calculations and make exquisitely precise predictions about electronic structure, what the electrons are going to do. But for the everyday laboratory work, there's an awful lot of stuff that you do with some really pretty coarse approximations. But there's nothing wrong with that if it actually allows you to do amazing stuff like curtains.
Are you both running a soft furnishing shop? All we're hearing tonight, you go, and something like this lovely jacket, which is actually available from Ryan's and Sellers.
All the advances we put down to living in the technological age, living in our information age, what percentage of those actually have nothing to do necessarily with the physics of it, but are to do with material science, creating smaller transistors? How many of them come down to chemists' work necessarily rather than some greater theoretical base?
So my favourite example is, is the iPod. So you couldn't have an iPod without having an understanding of quantum mechanics, because you couldn't have electronics. But so you could have a theoretical iPod if you're a physicist, right? But to have one in your hand, right? You need chemistry to do the photolithography to write the circuits. You need chemistry to make the liquid crystal display. All of those things, all of those manifestations. And that's where chemistry and physics works really, really well together. Because you can come up with, a great idea that looks great on paper, and then you need to bring it to life. You need to make it into stuff. And the thing about chemistry is it is the science of stuff.
Just tell me, because I had to leave at a very early stage of all this, how far do Bunsen burners stay in the system, and was that just silliness for schools, or that actually, are they actually of any use?
Bunsen burners are gone. They're pretty well gone, but mainly because of the health and safety.
Is in Bunsen burners.
It's health and safety gone mad. That's where the Bunsen burners have gone.
Do you have to breathe on them now? How do you have to do it?
No, the thing that they're still useful for is sort of doing little bits of glass blowing and that sort of thing. But that's just about it. And even that is going. It's very sad. I miss getting burnt with a Bunsen burner.
So the joys of watching a fourth form boy with curly hair and suddenly the smell as it goes, that's all gone.
Absolutely. No, it's gone. It really is.
There's nothing better than watching someone with an elaborate hairstyle, especially during the Smiths time as well, where people would get that quiff that just went right over the Bunsen burner. Yeah. You've got the hairspray in it. That was chemistry in action.
And then you got biology and medicine.
Could I just raise another sort of mystery of the universe, which of course is related to Brian's hair? Brian, do you ever have bad hair days? No. No, because I just have different wigs depending on how I do. Okay, all right. There's just an astonishingly long pause there. But something that people who, unlike me, actually do have hair, have problems with is occasionally real problems with static, their hair kind of standing up or whatever. And one of the interesting things is that I think there's increasingly a divergence between the chemists and the physicists over what that's about. And so, what is static electricity and where does it come from? I was just wondering whether you wanted to give us a physicist's view of...
You're clearly right in the sense that you've got to move electrons around at some level, but moving electrons off things and redistributing charges is dependent, I suppose, on the structure of the molecules eventually.
Well, I've brought something because I'm incapable of talking without fiddling.
Can I just say this is proper chemistry?
Okay.
He brings props. They bring their blackboards occasionally and what's in their mind. You bring props.
Now
I'm glad to see that.
what I've brought, I actually went to a high street shop that I won't name, and I went in there and I said, have you got any scarves? And they said, what color do you want? And I said, well, I don't care. And they said, do you want a man's scarf or a woman's scarf? And I said, I don't care. Just show me scarves. And so I started looking at the scarves. And eventually I picked out this nice pink one, and the woman said to me, no, you don't want that because it's really staticky. And I said, no, that's exactly the one that I want. And so if you take the scarf and you rub two scarves together, of course, it's very hard for people to see this on radio. Okay. You see, I think it's kind of a challenge to do this sort of thing on the radio. I don't know whether you've noticed that I'm rubbing the two scarves together. And
I haven't noticed. It's radio.
Yeah. Well, one of the interesting things is that here we have an organic material which on sort of gentle and affectionate handling is beginning to sort of rise to the occasion, standing up.
Okay,
now,
for the people
now, the question is,
now looks like a Fraggle.
It's not a bad description. So the interesting question is, why does that happen? And you've immediately sort of said electrons, and that's a one way of thinking about it. But one of the questions the chemist then asks is, well, wait a second. I mean, all I'm doing is I'm stroking these two things together. And if one material is pulling electrons off the other, what's the energy cost of taking it off on one side and putting it down on the other? And if you start looking at what the costs are, you realize that it's actually completely unaffordable. There's just not enough thermal energy at this temperature to pull electrons off just about anything. And so the question is, where does the charge come? And I mean, these things are wonderful. You move your hands around them. They're clearly charged. They like my hand. You can pull the strands of this scarf against my hand. Where is the charge coming from? And so one of the things that chemists are starting to say is, well, maybe there's more to the world than simply dividing it into electrons and everything else, right, which is the kind of reductionist physicist view. And that perhaps there's more to it, and it's all about ions. And you go and take a look at your hair care products, and sure enough, they're all sort of surface things. They're things that put ions in the right place and which ensure that you don't get this strange rise behavior out of hair or scarves.
Quaternary polyammonium compounds to you.
It's a scarf to me. And by the way, thank you for inventing the colour pink. Particularly good on that.
The thing that I find sort of extraordinary about this is that there are phenomena out there which don't require the LHC and which are, in a sense, unexplained. And that's, we walk across the carpet here, go off stage, you touch the door handle, and you get a shock. And where does that shock come from? And the weird thing is that there are people trying to figure that out, and they're doing some very, very cunning and deep experiments to do that without needing a city under Switzerland.
But what I wonder is, at school, chemistry, people seem to love chemistry because of that kind of the chance to experiment, the bangs and the pops, etc. And yet, really, when people become adults, chemistry seems to get forgotten. And physics is the one where we see, people will be drawn to books by Brian Greene, by Stephen Hawking.
Okay.
They'll be fascinated.
Well, Brian Greene and Stephen Hawking write books about space and about the structure of space, and that is something that falls well outside your remit, if you want to say. Like that, those kind of cosmological questions will remain enormously interesting forever to people. I mean, if there is a point where the two of them cross over, it'll be on the small rather than the large, to a huge extent. I mean, and relativity and the manner in which we discuss the warping of space and all that. That is physics' sole domain to a certain extent. Like that is one thing, and that is also one of the things which is most exciting to the human imagination. So I think physics will always have that part of it. It's the battleground is in the small. Am I right? Would you right in saying that?
I suppose. Just like chemistry, physics is a very wide discipline. I mean, what we've been talking about here, that Robin mentioned, things like the Large Hadron Collider, so particle physics, fundamental physics. I mean, that's actually interesting. I said fundamental physics there, and I shouldn't say that, because that riles virtually every other scientist, and it's correct that it should, because everybody's doing... Everybody, yeah. I know, we had this debate last time you were on, I think, Tony, because it is true that we're all asking fundamental questions, and as you said, even the question of static electricity, it's a fundamental question, and interesting in itself because we don't know the answer. But it is interesting that, as Dara said, that from a public perspective, I suppose these big questions like the Higgs field, the origin of mass, it's very interesting because it is an esoteric question in a sense, the origin of mass in the universe. But I think for some reason, because it's a question about the universe as it was a billionth of a second after the Big Bang, it's easier to speak about than something that's rather more familiar, such as static electricity? And that's an interesting question, actually, as to why that is.
Well, and it's easy to, or it's more comfortable to think about the big things that you can't really have any control over and perhaps struggle to understand than dealing with the nitty-gritty of where we are, as a society in a world with a booming population, energy supplies running out, nuclear power, and all of those things are all tainted with, oh no, it's got chemicals in it. And that's why I think that, popular science is entertainment, it's escapism, and it doesn't want to deal with the things that...
I don't think necessarily that's escape that it doesn't want to deal with. That's a little harsh on those who trade in it. But I certainly think that it's an easier sell to go, I shall now explain to you the mysteries of the universe, than I shall now explain to you a scarf. Or I shall now explain to you why the lights are going to go out, or why you're going to starve, or why there's going to be wars over resources, right? Because all those, all that's the matter of chemistry. And all those issues are things that people don't want to hear about because it means you have to change the way you live, right? Whereas, isn't it lovely? Look at the universe. It's marvellous.
I'm going to ignore that.
Richard Feynman was once asked if all information was removed, if the whole history of science was gone, what was the one sentence that could remain? By the way, we have no idea how this situation would arise, that there would just be one sentence left. But he said, all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. In that one sentence, there's an enormous amount of information about the world. Now, as chemists, how do you feel, would that be a good starting point, or do you feel if we're left with this bizarre situation where the one sentence of information, what for you do you think should be enshrined?
I think one would lengthen the sentence just by saying that the tiny particles, the little atoms, can link together. And I think with that, then that sort of immediately leads on and says, hey, you got potential for chemistry and a whole pile more. He was too much of a physicist, I think.
Brian,
Feynman, too much of a physicist.
That is why he got the Nobel Prize, though, right?
Yeah. So, over 30 years on from that summary by Feynman, would you say that's still a good starting point?
I suppose the standard model of particle physics is, at the moment, with Einstein's theory of general relativity, it tells you the fundamental... as we know it today, the fundamental building blocks of the universe and how it works. So with those two things, this goes back to what I said at the start. With those two things,
could you put that into one sentence, the standard
principle,
model?
Well, you can, yes, you just put commas in it. Huge sentences. Right.
That's the most artsy you've been for years.
Those would be... that would contain, in principle... all the information we know about the universe at the most fundamental level at the moment.
Would it not be more useful to get something that would underpin them all? I'd just write the method. If you had one sentence that told you method, if the one sentence that was handed over was hint, colon, measure that again. So you had the method of it so people knew to test stuff. Would that be more useful to you than actually trying to...
a significantly better answer than the one that I gave. Yes.
So just finally, I wonder when people are, perhaps some people listening who might be just trying to should I do chemistry, should I do physics, which way should I go forward, and they are in, again, a situation where they're going to do one. Is there an experiment or is there an idea which you think actually can really hook people in? Like I said, I think in school days people seemed to be more hooked into chemistry because of the excitement, the fact that it was a show, and physics seemed sometimes impenetrable. And then in later life it seems to swap around. So how would you lure people into... Well, obviously you'd lure them by making some kind of chemical that would make them sleepy and then tie them up. But that's not the point. How would you...
So for me, I remember a teacher mixing two liquids, one sat on top of the other, and then pulling this really, really strong solid out that had formed at the interface and wondering what happened in that flask, right? But there is that moment of creativity that you get in a chemistry lab when molecules are interacting, making new molecules. That's it's a bit like magic. And getting wanting to understand why it's not magic, why you can do it again and again and predict what's going to happen, is what got me hooked.
Andrea, have you?
Well, I think my moment was actually kind of similar, but slightly different. And mine wasn't visual. I was absolutely blown away by the smell after you'd made something. It was the complete change between what you'd started with and the product. And we made, must have been pear drops or something like that. But you started quite acrid, and then at the end, there was something magical and evocative, and it just got somewhere that nothing else could. And so I think you want to get people with all 5 senses, including taste and smell. You should always eat your products.
I had a chemistry set when I was about 14, and I made hydrochloric gas, and I smelled that. Yeah. That was the end of my smelling for a while, to be honest. So yeah, don't just shove your nose into any beaker. That's
so, would you give an example then of something if you think the idea? I mean, I know it's harder with an experiment, but the idea you think just hooks people in, which gives them the excitement about what possibly the world of physics holds.
Well, I think at the moment with the new LHC results and the investigation of the subatomic world that spectacular machine is embarked upon, I think this idea that you can predict real things about the universe using quite simple theories and mathematics, and then almost 50 years later build a machine that appears to be on the edge of confirming that prediction. And I think it's one of the remarkable human achievements, actually.
And in defence of English and drama, which I studied, I'm very incisive when it comes to interpreting Beowulf. This was the chemistry or physics and why. That's what we asked the audience, chemistry and physics, or physics and why. This is from Martin, chemistry, because if it smells, it's chemistry, if it moves, it's biology, and if it doesn't work, it's physics.
Here's one from David, it's chemistry, because you don't talk about physics in a relationship.
This is Ellie Mills. Physics. With physics, things can only get better. Chemistry. If something doesn't work, you can't pretend that it does by sticking the word dark in front of it. Michael Fletcher. So, there we go. Next week, we'll be doing philosophy versus whistling. Which makes you happier? It's whistling. And if you would like any further information on the subjects covered today, good. Next week we are on Boxing Day for our Yuletide Christmas special. We'll be joined by the ghostly apparition of Sherlock maestro Mark Gatiss and the modern-day Bacchic celebrant Richard Dawkins, as we will be looking at the science of Christmas.
Mainly psychotherapy, then?
That will mainly be psychotherapy on Boxing Day. So we look forward to joining you during your indigestion. Goodbye.
Goodbye.
If you've enjoyed this programme, you might like to try other Radio 4 podcasts, including Start the Week, lively discussions chaired by Andrew Marr, and a weekly highlight from Radio 4's evening arts programme Front Row. To find out more, visit bbc.co.uk/Radio 4. This is a download from the BBC. To find out more, visit bbc.co.uk/Radio 4.
Ladies and gentlemen, boys and girls, XX and XY of any age, welcome to a no-holds-barred, bare-knuckle, infinite monkey cage fight. Because today we have the fight of the century in the left corner, presenting a majestic view of a universe populated by 350 billion galaxies, countless stars and planets of unimaginable beauty, weighing in with masses generated through the interaction of their particles with a...
And I'm Brian Cox, and I refute the accusation with all the strength of a homeopathic nuclear power station.
They're perfectly safe, but why won't my light switch on?
Joining me to battle this out is a man who studied mathematics and theoretical physics at University College Dublin, but went on to become a stand-up comedian. He occasionally mixes the two, but finds that any joke that starts, if we take X to be the IQ of a man who walks into a bar, Y to be the IQ of the parrot on his shoulder, and Z to be the height of the bar in feet, and Z is greater than Y is greater than X, then you must be at an...
Condensate filling every corner of the universe with an energy density of a staggering 10 to the 37 joules per cubic metre. That's the power output of the sun in 1,000 years. It's physics! And in the right-hand corner with coloured liquid and funny smells, it's chemistry. I'm Robin Ince, and in the interest of truth, I'd like to make it clear that Brian Cox wrote the chemistry introduction.
Equine Reiki and Feng Shui Acupuncture and Astrological Homeopathy Convention doesn't play well at Equine Reiki and Feng Shui Acupuncture and Astrological Homeopathy Conventions.
Though, that said, Brian, I've noticed that our invitation to speak at Equine Reiki and Feng Shui Acupuncture and Astrological Homeopathy Conventions have diminished since this show started.
Yes, it's the primary non-exponent of Equine Reiki and Feng Shui Acupuncture and Astrological Homeopathy, Dara O'Brien.
Well, we will, you've seen who represents physics there, that's Brian and Dara, but representing chemistry in a fug of ether and stinking of something sulphurous is our first fighter for the chemistry way. He's the BBC's go-to inorganic chemist if you want a demonstration on how alchemists distilled urine with the hopes of creating true gold, and therefore has a very small social circle. He is Andres Sella, and we have someone who will be our first guest who appeared 3 times on this show so far. He is the Pro-Vice-Chancellor of Sheffield University and a chemist. His last appearance in the Monkey Cage culminated in the call for the crowds at Glastonbury to mince more in order to avoid sinking